Okay, so today's lesson is going to be over input-output tables. And I want you to think of these as like a machine, or when you go to Chuck E. Cheese or Peter Piper Pizza or wherever, and you're inputting your tickets, and it's outputting how many, it's counting it and stuff, and it outputs something, right? So you're inputting something, and the machine's doing its thing, and it outputs something. And that's the same thing that's going to go with these input-output tables. All right, so the function table shows the relationship between inputs and outputs. A function rule for this particular table is that the output is equal to 4 times whatever I'm putting in. So something that you need to always remember is your input will always be X, and your output will always be Y. So my output is 4 times whatever. So every time I'm putting something in, it's getting multiplied by 4, and then it's spitting out your output. The thing with these input-output tables is you have to make sure that your function or your rule works for every single problem. Because I'm telling you this because sometimes your input, you could say, okay, well, what am I doing to 1 to get to 4? Well, I could add 3. Does 1 plus 3 give me 4?
Yep.
Yeah. So if I just looked at the first one and said, oh, I'm adding 3 and moving on, but I need to go through and make sure it works for all of my inputs. If I input a 2 and add 3, is it going to output 8? No. So then that rule would not work. All right, you can use the function rule y equals 2x plus, oh, this is a different question. There we go. So in order to, we said our output was equal to 4 times our input. So when I write it, we're not going to write the word output and input. We're going to use x and y. And so this would be y is equal to, my output is equal to 4 times whatever I'm putting into it. That would be my equation for that rule, for that table. So sometimes I might give you what x is, and I'll give you the rule, and you have to come up with what y is. So I know it already kind of gives you the answer, but I want you to get used to putting that. So here's my input, right? Here's my output. This is my rule or my function. What's being done to the machine when you input that? When I input a 0, it's going 2 times 0 plus 3. That's going to give me an output of a 3. Okay? So with input output, it's really a simple thing because it gives you the rule. If it gives you the rule, then you just go ahead and just plug in those numbers. So let's look at some examples of these. And I know it's kind of blurry up there, guys, but it's right in front of you. All right, write input-output function rules for each table below. First thing I'm going to do is I'm going to label them X and Y. I need to get used to, when I hear the word input, my mind should automatically see the letter X. When I see output, I automatically see Y. Okay, those need to go hand in hand. All right, so the first thing I'm going to do is I'm going to, let me zoom in here. I am going to say, what am I doing to 3 to get to 6? I am multiplying by 2. Would y'all agree? But before I say, oh, that's it, I'm moving on, I'm going to see if it works for all of them. So 3 times 2 equals 6, yes? Does 4 times 2 equal 8? Does 5 times 2 equal 10? And 6 times 2 equals 2? Yes? 12, sorry. Times 2 equals 12. So my rule, and because y'all are pre-AP, I want you not just to write multiply 2. I want you to write the whole equation. So you're going to just have to get used to it. This is the difference between pre-AP and regular. So regular would just write multiply 2 by 2, but y'all as pre-AP will write y equals, my output equals, what am I doing? 2 times my x. So everybody understands that you have to write this whole equation to get credit. Yes? Yes, for my pre-AP students, the whole equation. All right, looking at number 2, what am I doing to my input to get to my output?
+2.
All right, let's see if it works. I heard a +2. So does 1 + 2 equal 3?
Yes.
Does 2 + 2 equal 4?
Yes.
Does 3 + 2 equal 5?
Yes.
Does 4 + 2 equal 6?
Yes.
So my rule is adding 2, right? So my rule or my function would be y is equal to x plus 2.
And you can also do 2 + x, right?
Yes, you could do 2 + x, but I want you to get used to just writing it. I mean, 2 + x and x plus 2 is going to give you the same thing. All right, so go ahead and I'm going to give you a few minutes. I want you to do number 3 by yourself. So you're thinking to yourself, what am I doing to my x or my input to get my output or my y? Does it work for every one of my inputs? How do I write that equation? So what do we get for our equation? Raise your hand. Landry.
Times 45.
Nope, that is not my equation. Remember, we're pre-AP, so I want it done correctly. So go ahead and tell me again. Take your mask down just a little bit so that we can hear you.
Y equals 45x.
Very good. Y equals 45x because I'm multiplying by 45 each and every single time. Did y'all agree? All right. It says, make a table for the function represented by each rule. Find y when x is 0, 1, 2, and 3. So here, this is the ones that I like. All I need to do is I'm going to look at my equation that they give me, and I'm going to plug in each of these. So I'm going to do 10 times 0, 10 times 1, 10 times 2, 10 times 3. What is 10 times 0?
0.
0. So my output is going to be 0. 10 times 1?
10.
10 times 2?
20.
10 times 3.
30.
Does everybody see that? And then, and although this isn't what we're doing right now, eventually we're going to be able to go ahead and plot these on the ordered pair. So that's where this is going to be using this as an ordered pair. So know that this is where we're going with that. All right, let's do number 5. 0 minus 4 is going to give me what?
-4.
-4. All right, 1 minus 4 is going to give me
-3.
-3. 2 minus 4 is going to give me
-2.
perfect. 3 minus 4 will give me
-1.
perfect. Pretty easy, isn't it? Yeah? All right, let's try this one over here. 2 times 0 plus 4. 2 times 0 is?
0.
Plus 4?
4.
Perfect. 2 times 1 plus 4.
6.
And 2 times 2 plus 4.
8.
2 times 3 plus 4.
10.
Perfect. So when you're showing your work, I want to see these numbers plugged in here, right? And I want to see your rules. This is kind of what I need to see from you as far as work. Go ahead and do number 7 on your own. All right, so we've got 3 times 0 minus 1. Did y'all get -1 for your first y?
Yep.
Perfect. And then I got 2. And then 5. And 8. Perfect. Perfect. All right. So let's look at number 8. A printer can print 9 black and white pages per minute. Write a function rule to represent the relationship between the number of black and white printed pages and the time it takes. How many? So I'm going to go ahead and I'm going to make me an input-output table. And I know this being the minutes, and this is the printed pages. So at 1 minute, it prints off how many?
9.
9. What about at 2 minutes?
18.
3 minutes?
27.
4 minutes? 36. So what would my rule be?
Times 9.
So what would my equation look like?
Y equals 9x.
9x?
Yes.
Perfect. Now, knowing this, I can be able to find out any of them. How many black and white pages can be printed in 15 minutes? So I'm going to do 15 times 9. So 9, 10, 11, 12, 13. So you get 135 pages. With me on that? Yes, no? How long would it take to print 75 black and white pages? So remember, X was my minutes, Y was my pages. So if I were to plug this in, I would be 75 is equal to 9X. How do I solve that?
Division.
I'm going to do what to both sides? I'm going to divide by,
9.
cancels out. And I'm going to do 75 divided by 9, which is going to give me 8, 72. Think, 3. And it's going to keep repeating, so 8.33 repeating, right? Or I could have written 8 1/3 minutes.
Teachers, please pardon the
All right.
interruption. Please release
So that ends our
the
lesson.
UIL